In this video, we're going to focus on what we call Descartes' rule of signs. And essentially what it is a nifty little trick for when solving polynomials to find out how many possible positive and how many possible negative zeros that there are with the function. So we say, given some function here, Descartes' rule of signs, we say it has some polynomial function written in standard form, but we say it's a polynomial function with real coefficients. So long as this is true, we say the number of possible positive real zeros of f is either the same as the number of sign changes of f of x or letter B here. Now, I'm not going to get to letter B yet. I want to go back and talk about letter A. It says it's the same as the number of sign changes of your original function. So when we talk about sign change, taking into consideration this function you see up here, the 7th degree thing that's written in standard form and has all real coefficients. When we look at this, when we talk about sign changes, we're talking about if our sign varies or it changes from being positive to being negative, or negative to positive from term to term. So you see it goes from being negative to positive here. So they consider this to be a sign change. When we say negative to negative, that doesn't count because it didn't change. But it did change from negative to positive here. So that's a sign change. Positive to positive didn't change, and then positive to negative here. Excuse me. And so, for this 7th degree function right here, what we could say is that the possible positive zeros that exist for this, I could say 3. Now, the other thing is this part B. It says it's either the same as the number of sign changes, which were 3 sign changes for this f of x up here, or less than that number of sign changes by an even number. So what we mean here is this. If we say 3 is a possibility, we have to count down by 2's from here. So basically 3 minus 2 would be 1. So I'm going to write this here as a matter of fact. Instead of 3 comma 1, I'm going to write 3 or 1. Those are the possible positive number of positive zeros that this function could have. So now to check for negative real zeros of f, what we're going to do is the same thing. We're going to count sign changes, but we say it's the same as the sign changes of f of negative x, or less than that by an even number. So essentially what we're going to do is we're going to plug in a negative x into our function, and we're going to count the number of sign changes there, or count down by 2's. So for something like we have up top here on the right side, let's take a look at how we would put this into use. We would say, given this f of x here, this cubic thing, x squared plus, or x cubed plus x squared plus 2x plus 5, we say how many possible positive zeros could it have, and then also how many possible negative zeros can it have. So we'll start with the positives. And counting sign changes, I notice that it goes from being positive to being positive to being positive to being positive. So what this means is that there are 0 possible positive here, or we can write in parentheses, there are no possible positive zeros for this function right here. Now in terms of possible negative, we said we were going to need to go find f of negative x. So that's what we're going to do here in this instance. We say f of negative x would be the same thing as if I went to all of these spots having x's and plugged in a negative x. So I would get this right here. And in this case, we're not checking to see if this function's even or odd. What we're checking for are variations in sign. So you notice that anything that has an odd exponent, those are things that are going to change their signs. Anything with an even exponent, when you multiply a negative thing times itself an even number of times, it'll always come out to be a positive. So for instance, this plus a negative x squared will become a plus a positive x squared, while this negative x cubed would just be a negative x cubed. The same thing here, a positive 2 times a negative x is a negative 2x, and then I have my plus 5 I'll just bring down. So counting variations in sign, I would say that we have a variation here, we have a variation here, and we have a variation here. So possible negative zeros of this, we either have 3 negative zeros or we have just 1 negative zero. So we said no possible positives, 3 or 1 possible negatives. And what I've done is I've actually graphed this here in the Desmos. We notice that we get 1 0 here and it happens to be negative. And so going back and looking at our test here, we notice that this is represented by its graph right there. It doesn't have to be the 3. So now looking at letter B here, we notice that this was a cubic with all of its terms listed. This is some cubic, but not all of its terms are listed. But I do want you to notice that it's in standard form. So when we talk about the possible positive or possible negative, we say the possible negative, sorry, I was looking at that or writing it, so I said negative. The possible positive are equal to the variations in sign of just plain old f of x. So how many variations do we see up here? I'd say I see 1 there from negative to positive and positive to negative. So I would say 2 or less than that by an even number. So we say 2 or 0. And then we say possible negatives, we would plug in a negative x and see what we end up with here. So we get negative x cubed plus negative x minus 5. And I notice that this here is going to be negative x cubed, which makes it a positive x cubed. Here we get a positive negative x, which makes it a negative x, and then we get a negative 5. So in terms of variations in sign, I see one here from the positive to the negative, but not from the negative to the negative. So we'd say just one possible negative 0 for this function. So 2 or 0, possible positive, and 1 possible negative. Going and looking at its graph, looks like it has 1 negative, so that matches up with the fact that we could have gotten exactly 1 negative here. Actually, we had to get 1 negative. And then we would say that in terms of possible positive here, we say 2 or 0, it looks like this graph has none. So that's Descartes' rule of signs and how it helps you determine the possible positive and negative real zeros for your functions. Cheers.